Right now, sitting exactly where you are, you believe two things that are completely false. You believe you're sitting still, and you believe gravity is pulling you down into your chair. Both wrong. At this very moment, you're accelerating, being shoved upward, and gravity is pulling on you exactly zero. Nothing. If that sounds insane, good, because the thing we all call gravity might be the single biggest illusion your brain has ever fallen for. And once you see through it, you can't unsee it. So here's the deal. There's a question so simple that a 4-year-old at a dinner table can ask it and shut down an entire room of scientists. Why do things fall? Not how, why. Newton couldn't answer it. Your physics teacher probably dodged it. And the wild part? Even Einstein, the guy who cracked it wide open, basically shrugged at the deepest version of the question. Stick with me, because in the next few minutes, I'm going to take the most ordinary thing in your life, stuff falling down, and turn it completely inside out. Let's start with the man everyone credits, Isaac Newton, the apple, the tree, the whole legend. Here's what nobody tells you about Newton. He never explained gravity, not once. What he did was describe it, and he described it so unbelievably well that we've been coasting on his math for 300 years. He gave us a formula, two masses, the distance between them, and out pops a number that predicts how they'll move. Planets, moons, tides, cannonballs, all of it, nailed to absurd precision. But here's the thing that quietly haunted Newton for the rest of his life. His own theory said that the sun reaches across 93 million miles of empty nothing and yanks on the Earth instantly with no rope, no contact, no explanation. Action at a distance. Newton himself called that idea absurd. He wrote that no thinking person could really believe it. He had the equation. He just refused to pretend the equation was an answer. And that's your first lesson in real physics. Describing something and understanding something are not the same thing. So for 2 centuries, gravity sat there, perfectly predicted, completely mysterious. Then a patent clerk with wild hair had a thought that changed the shape of reality. Literally, Einstein asked a weird question. What does a person actually feel when they fall? And the answer is nothing. A skydiver in free fall before the parachute opens feels totally weightless. No pull, no force, floating. Which is bizarre, right? The one moment gravity should be screaming at you the loudest, you feel it the least. Einstein called this the happiest thought of his life, because it flipped everything. What if falling isn't being pulled by a force? What if falling is just what things naturally do when nothing is pushing on them at all? Okay, pause. Let me make this real with a trick you can run in your own head right now. Imagine you're in a windowless elevator out in deep space, far from any planet. Now imagine a rope yanks that elevator upward, speeding it up at just the right rate. Your feet press into the floor, drop a ball, and it falls to your feet. You'd swear you were standing on Earth. Now flip it. You're in that same windowless box, but this time it's actually sitting on the ground on Earth. Same exact feeling. Feet on the floor. Ball drops, here's the punchline. There is no experiment you can do inside that box to tell the two situations apart. Being pushed by a rocket and being held by gravity feel identical because, and this is the earthquake in the middle of physics, they are the same thing. This is called the equivalence principle, and it's the crack that split the old universe wide open. Now let's follow that crack to where it leads, because it's about to get personal. If accelerating upward feels exactly like gravity, then think about what's happening to you right now. You feel your chair pushing up on your body. That push is a real force. It's electrons in the chair, shoving electrons in you, but the ground under the chair is pushing the chair, and the earth is pushing the ground. Every bit of it pushing you upward. So here's the mind bender. You are the one accelerating. The chair is constantly shoving you off the path you'd naturally take. And what is the path you'd naturally take? Straight down. Falling. Free fall isn't the weird state. Free fall is the natural, restful, zero-force state of everything in the universe. Sitting still is the strange thing. You are being actively pushed every single second of your life, and you've just gotten so used to it that you call it normal. But wait, if gravity isn't a force pulling things down, then what on earth makes the falling path curve toward the ground in the first place? What steers the apple? Here's Einstein's answer, and it's genuinely one of the most beautiful ideas humans have ever had. Space isn't an empty stage. Space and time are woven together into a kind of fabric. Spacetime, and anything with mass bends that fabric. The sun sits in spacetime like a bowling ball on a stretched trampoline, sinking it into a deep well. The Earth isn't being pulled by the sun at all. The Earth is just rolling in a straight line, but a straight line through curved space looks like a circle from the outside. Let me say that again because it's the whole ballgame. The planets aren't being tugged. They're coasting in a straight line through bent space. And the bending is what we've been calling gravity this entire time. The apple doesn't fall because Earth grabs it. The apple falls because Earth has dented the shape of space around it. And the apple is simply following the natural groove. Now, I told you at the start that this breaks your intuition, and here is where it truly does. I've been saying space bends, but it's space-time. And that means gravity doesn't just bend space, it bends time. Here's a fact that sounds made up and is 100% real. Time runs slower the closer you are to a heavy object. Your feet right now are aging very slightly slower than your head, because they're a little closer to the center of the Earth. And we can actually measure this. Scientists have taken two of the most precise clocks ever built, put one just a single foot higher than the other, and watch the higher one tick faster, 1 foot. And this isn't some useless lab curiosity. The GPS in your phone would be broken without it. The satellites overhead sit in weaker gravity, so their clocks run faster than yours. And if engineers didn't correct for Einstein's math every single day, your Maps app would drift you miles off course within hours. Your phone is quietly proving Einstein right thousands of times a day. And here's the deepest version of why things fall. Objects don't just move toward mass in space, they drift toward where time itself runs slower. Falling is stuff sliding toward slower time. Let that sit for a second. Let me hit you with one more thing nobody mentions, because it makes the whole story even stranger. For all this cosmic drama, gravity is pathetically weak, the weakest force in the universe by an almost comical margin. Don't believe me? Grab a fridge magnet, a cheap little one, hold it over a paperclip. It jumps up and sticks to the magnet. That tiny magnet just beat the gravitational pull of the entire planet Earth. All 6 trillion kilograms of it, out-muscled by something you got free with a pizza menu. So the force that runs the cosmos, that holds galaxies together, bends light and steers planets, is also the biggest weakling in all of physics. It only wins because it never quits. And because it only ever adds up, it never cancels out. Pile up enough mass, and this feeble little effect becomes a black hole so strong that not even light can escape. So let's bring it home. What is gravity really? It's not a rope, it's not a pull, it's not even really a force, it's geometry. It's the shape of reality itself. There's a single sentence that captures the whole thing. Mass tells spacetime how to curve, and curved spacetime tells mass how to move. That's it. That's the universe's oldest trick finally exposed. But here's the part I love most, and it's pure Feynman. Even with all of this, the curved space, the bent time, the gorgeous equations that predict everything to a dozen decimal places. If you ask the deepest question, the one the 4-year-old asked, why does mass bend spacetime in the first place? Nobody knows. We have the most beautiful description in all of science, and underneath it sits an honest, wide-open mystery, and that's not a disappointment. That's the whole point. Real understanding isn't a locked box of final answers. It's standing right at the edge of what humans know, staring out into the dark and feeling that itch to see just a little further. Gravity taught us the most important lesson in all of physics. The universe is under no obligation to make sense to you, and it is 1,000 times weirder and more wonderful than the version they taught you in school. If any part of this rewired how you see the ground under your feet, do me a quick favor. Hit that like button. It genuinely helps this channel way more than you'd think. Subscribe if you want more of the stuff nobody told you about the universe. And I want to hear from you in the comments. What's one everyday thing you thought you completely understood until you really looked at it? Drop it below. I actually read them. I'll see you in the next one. And until then, keep looking up, even if up turns out to be a lot weirder than you thought.